Today I'm going to go over your Unit 7, which is Chapter 9, test review over polar coordinates. So first we're going to look at a coordinate and we're going to name the ordered pair, r and theta, that goes with these in each of these ways. So first, the A has an r value of 2. So that'll be 2, those will be negative 2. Okay, so then we just need to come up with the corresponding angle. Remember, positive angles are going counterclockwise, negative angles go clockwise. So to go to this point, that's just going to be pi over 4. If I start here and go the other direction, that's going to be 7 pi over 4. To get to the negatives, I start at the negative 2 and then go counterclockwise, which is 5 pi over 4. Then I'm going to go to that, start at negative 2, but going clockwise is 3 pi over 4, which would be negative. Okay, now let's look at B. B has an r value of 4. Then we just need to figure out the corresponding angles. So if I start at 4 going counterclockwise, that's going to be 240 degrees. If I start at 4 going this direction, that's going to be 120, so negative 120. And if you add up the absolute value, we get 360. Okay. If I start at negative 4 going counterclockwise, we're just going 60 degrees. Going the other direction is going to be 300. Okay, so now we're going to convert from polar form to rectangular form. The formulas are really easy. X is going to be our cosine theta, y is going to be our sine theta, and our thetas will all be unit circle values, so we can use the unit circle to evaluate those. So here, my x is going to be 2 cosine pi over 3, y is going to be 2 sine pi over 3. You go to your unit circle. The x value at pi over 3 is 1/2. So my x coordinate is going to be 1. The y coordinate is root 3 over 2. So my y is going to be root 3. So my coordinate is 1 root 3. X will be 5 cosine 5 pi over 6. Y is 5 sine 5 pi over 6. Using our unit circle, the x value at 5 pi over 6 is negative root 3 over 2. So this will be negative 5 root 3 over 2. The y value at 5 pi over 6 is positive 1/2. So this will be 5/2. So my coordinate is going to be negative 5 root 3 over 2 and 5/2. Negative 45 degrees. That's going to be the same as 315 on the unit circle. So x will be 3 cosine negative 45. Y will be 3 sine negative 45. At 315, our x value is positive root 2 over 2. My y value at that point is negative root 2 over 2. So my coordinates will be 3 root 2 over 2 and negative 3 root 2 over 2. Okay, last one in this section, x equals 1 cosine 210, y is 1 sine 210. The cosine of 210 is negative root 3 over 2. Our y value is negative 1/2. So those are our coordinates. In this next section, we're going the other direction, starting with the rectangular and ending up at the polar. The r is going to be the square root of x squared plus y squared. Theta is going to be the tangent inverse of the y value over the x value in the correct quadrant. So it's a good idea to have your unit circle labeled with all of those tangent values. All right, so our first one is positive 1/2 root 3 over 2. So r is going to be the square root of 1/2 squared plus root 3 over 2 squared. We don't worry about the negative because it'll go away. So 1/2 squared is 1/4. Root 3 over 2 squared is 3/4. So this is the square root of 1, because that would be 4/4. So we get 1. Theta is the tangent inverse of negative root 3 over 2 over 1/2, which is going to be the tangent inverse of negative root 3. This is going to be in the fourth quadrant. So you're looking for the fourth quadrant tangent value because it's positive, negative. So that's going to be 5 pi over 3. So my coordinate here is 1, 5 pi over 3. Okay. For b, r is the square root of root 2 squared plus root 2 squared. So that's square root of 2 plus 2. 2 plus 2 is 4. Square root of 4 is 2. Theta is the tangent inverse of root 2 over negative root 2. Well, that's the same as tangent inverse of negative 1. So that's going to occur at 3 pi over 4 and at 7 pi over 4. But we want the one in the second quadrant. So that is 3 pi over 4. So my coordinate is 2, 3 pi over 4. For 3, 3, r is the square root of 3 squared plus 3 squared, which is 9 plus 9, which is root 18. And you can write that as 3 root 2 or just leave it as root 18. Theta is the tangent inverse of 3 over 3, which is the tangent inverse of 1, which occurs at pi over 4 and 5 pi over 4, but we want the first quadrant. So this is pi over 4. The last one I'm going to do by graphing. If I were to graph negative 5, 0, that's going to be this point here. Well, on the polar plane, this is 0, this is pi over 2, this is pi, this is 3 pi over 2. So my r value would be 5, and my theta would be pi. That's how we'd arrive at that value. Okay, now we're going to look at the relationship between rectangular and polar in equations. So we're going to graph the equation, we're going to find it in rectangular form, and solve for y when possible. So theta equals 315 is a line. The line at 315, 315 is down here, so it's going to be this whole line. Well, if it's 315, it's right in the middle. So this is just going to be a line. Y equals negative x. Okay, if it was here, it'd be y equals positive x. R equals 7 is a circle. For the graph, it's just going to go out 7 units. There's that. For our conversions, I know that r squared equals x squared plus y squared. So r squared, if I square both sides, I get r squared equals 49. So we get x squared plus y squared equals 49. we can either graph this from the rectangular graph or the polar graph. We do know it's a circle. Okay, it's going to be a circle symmetric to the x-axis. Okay, if I make a table of values, if my theta is 0, cosine of 0 is 1, so we'd get 3. If I plugged in pi over 2, we'd get 0. So here, we have a point here, and we have a circle that's symmetric to the x-axis. For the equation, I'm going to multiply both sides of this by r to get r squared equals 3r cosine theta, because then I can replace the r squared with x squared plus y squared, and I can replace the r cosine theta with x. And you can leave it like this. The alternative is to move it over and complete the square to get the formula for the circle. Okay. This one I'm going to convert to polar first, and then we can get the equation for the line. So this is going to be 4 times 1 over sine. So I can multiply over the sine. So r sine theta equals 4. R sine theta is equal to y. Y equals 4 is a horizontal line. So to graph it, there's 4. There's my horizontal line. In the next section, we're going the other direction. And these are very closely related. If you look at what we have here versus the section above, it's kind of the reverse. In fact, this one is the result of what we got here. But let's go through the math to show that. This is going to be a circle, but you might not recognize it at this point. So I'm converting. So I know x squared plus y squared is r squared, and x is r cosine theta. To solve for r, I'll just divide both sides by r to get that 3 cosine theta. So this is a circle. The graph is exactly the same as the one we did above. So I'm going to go out 3 and graph that circle. Here we know we have a horizontal line. For the graph, y equals -3. Then to convert it, we just replace y with r sine theta. To get r by itself, we divide. Okay, so you can leave it like this, or you can say that r equals -3 cosecant theta. Hopefully you recognize this one as a circle. It is centered at the origin with a radius of 5. X squared plus y squared equals r squared. Actually, sorry, r equals the square root of 5. So these are actually all square root of 5, square root of 5, square root, square root. Okay. And then our equation is r equals root 5. Okay, this one is also a circle. Its center is at 2, 0, and it has a radius of 2. So we're here, and then I'm going to go 2 in every direction, like that. Okay. So we said circle. To put it into polar form, I first need to expand this. So that'll be x squared minus 4x plus 4 plus y squared equals 4. The x squared plus y squared is r squared minus 4, x is r cosine theta. And then I can subtract 4 from both sides and get 0. Then I can move 4r cosine theta over, and then divide both sides by r. So we get 4 cosine theta, which we know that's a circle on the polar plane. Okay, we're going to be doing some graphing, and these are just the basic graphs. So if it's an r equals, that's going to be circle out that distance. So r equals 2 is going to be that right there. R equals -4 is also a circle. -4 is out here. So it's going to look the same as if we graphed r equals +4. For the theta equals, those are lines. So 30 degrees is right here. So it's going to be the line, and it's going to go all the way through. Okay, so we include both parts of this. Okay, and then our last one, -pi/3 is going to be the same as -60, and then we'll do that whole line. Okay, so that's basic lines and circles. So this next section, we're going to name the curve. Now this section on your test is going to be matching, so you just need to be able to recognize it. A cosine n theta is a rose. When it's squared like that, that's a lemniscate. Okay, these two are similar. If they're the same, it's a cardioid. If they're different, it's a limacon. R sine theta is a circle. And then these two we just graphed. R equals something is a circle. Theta equals something is a line. Okay, so a rose with this equation, 4 cosine 5 theta, is symmetric about, if this is cosine, it is guaranteed to be symmetric around the x-axis. It may also end up being symmetric to the y-axis, but at a minimum we know it's the x-axis. And how many petals? Well, it always depends on this number here. If this number is odd, like 5, it has that many petals. If it's even, then it's double, which we'll use in the next one. So write an equation that is symmetric to pi/2, or the y-axis, which means it's going to be sine, and has 4 petals. So it's going to be y equals any number, so you can write whatever. 1, 2, let's do 7. Why not? Sine, and then if it has 4 petals on the inside, we're going to have 2 theta. So again, this makes it symmetric to this. 2 theta makes it have 4 petals. 7's just there because. Okay, so we're going to graph this, and this is all no calculator, so you have to be able to graph these without a calculator. But we know a lot of information about this. We know this is a rose. We know it has 4 petals. We know at a minimum it's symmetric to the y-axis. Okay, past that, we can use the rectangular graph that corresponds to this to graph. So for the rectangular graph, the period is 2 pi/2, which is pi. And the amplitude is 4. So if I'm graphing the rectangular graph, this is 4, this is -4. I'm going to put pi here, which makes this pi/2, split each of those in half, pi/4, 3 pi/4. It's a sine, so it starts at the midline, then goes up. Sorry, that should end there. That was bad. So our curve, this is 2 petals. We can continue on. 2 pi. This is 3 pi/2, 5 pi/4, 7 pi/4. So we're maximum, midline, minimum. Graph it this way, we get the 4 petals, or you graph the first 2. Pi/4 out 4, 1, 2, 3, 4. That's a petal. 3 pi/4 is here, but it's a -4, so it's across here. So you can do this and reflect it over the y-axis because we know it's symmetric to the y-axis, or using our graph that I extended at 5 pi over 4, we're at positive 4, at 7 pi, we're at negative. Okay, it is symmetric to the y-axis. It's also symmetric to the x-axis, but that's our rows. Our next one, 2 plus 2 cosine theta. We know we have a cardioid. It is symmetric to the x-axis. And then we can create a table of values to graph this. So I'm going to plug in 0, pi over 2, pi, 3 pi over 2. Cosine of 0 is 1, so this is going to be 2 plus 2, which is 4. Cosine up at the top of the circle, the x value is 0. So this part will be 0 plus 2 is 2. Cosine of pi is negative 1, so that's going to make a 0. 3 pi over 2 is also 0, so this is 2. So those points, 0's out at 4, 1, 2, 3, 4. On the pi over 2, we're out 2. Pi is at 0. 3 pi over 2 is 2. And then I'm going to graph the cardioid, which I know looks like a heart. Okay, here I have another rose. It has 3 petals, and it is symmetric to the x-axis. The amplitude is 3. The period is 2 pi over 3. So I can graph our rectangular graph. So 1 pi over 6, 2 pi over 6, 3 pi over 6 is pi over 2, 3, negative 3. Okay, so this is cosine, so it starts at the maximum. We're looking for 3 petals, and we have them. So at 0 degrees, we're out at 1, 2, 3. At pi over 3, which is here, we're at negative 3. And then at 2 pi over 3, we're out at 3. Okay, they should always be the same distance apart from each other. So if you end up with like 2 that are closer together, that's not going to be correct. Last one we're going to graph here is a circle, symmetric to the x-axis. Again. So we'll create a table of values. Theta r, we'll do 0, pi over 2, and pi, and that's really all we need. If I plug in 0, cosine of 0 is 1, so we get 4. Pi over 2 is 0. Pi is negative 4. So on our 0, we're at 1, 2, 3, 4. Pi over 2 is at 0. And pi is at negative 4. So we have those 2 points, which isn't a whole lot to go on, but we know this is a circle. So let's go ahead and draw our circle. Okay, graphing on the complex plane. This is our real axis. This is our imaginary axis. 3 plus 4i. 1, 2, 3 plus 4i is there. Okay, super easy. Negative 2 minus 3i. That's all there is to graphing. Okay, in this next section, we are going to take a complex number in rectangular form and turn it into polar form by finding the r, finding the theta, and then putting it in polar form. Okay, r is equal to the square root of 3 squared plus 3 squared. We don't care about the I just is part of this. So this will be 9 plus 9, or root 18. Theta is going to be the tangent inverse of 3 over 3, which is 1. In the first quadrant will give us pi over 4. So the polar, or the polar form of the complex number is going to be root 18 on the outside, cosine pi over 4 plus I sine pi over 4. For -1, if I were to graph that on the complex plane, that's just going to be back here. So the r is going to be 1, theta is going to be pi. So this would be 1 cosine pi plus I sine pi. This one, r, square root of 1 squared plus root 3 squared. That's 1, that's 3. 3 plus 1 is 4. So we get 2. Theta is going to be the tangent inverse of negative root 3 over negative 1, which is the tangent inverse of positive root 3, which is going to occur at both 2 pi over 3 in the first quadrant, or in this third, we want 4 pi over 3. So again, make sure those tangent values are on your unit circle. So 2 cosine 4 pi over 3 plus I sine 4 pi over 3. Now putting complex numbers into polar form seems a little bit silly at first, but we found that it makes it so we can multiply, divide, and more importantly do powers and roots much easier. So we're given these already in polar form. We're going to multiply, divide, and do powers. So multiplication, W1 times W2, we're going to multiply the two r's, and we're going to add the two thetas. So pi over 6, I'm going to go ahead and write, this is 4 pi over 6, and then this one's going to be 9 pi over 6 when we need a common denominator. So we're going to add the thetas, which are pi over 6 plus 4 pi over 6 plus I sine pi over 6 plus 4 pi over 6. And then simplify. So 4 times 2 is 8 cosine 5 pi over 6 plus I sine 5 pi over 6. Okay, we want our answer in polar form, so we are done. Okay, the next one, W3 times W2. So now we're going to be multiplying these two. This time we're going to answer in rectangular form. So I'm going to multiply the two r's, which are 2 and 5, and then add the two thetas, whose common denominator is 4 pi over 6. Okay, so if I add these, we get 10, and then cosine 13 pi over 6 plus I sine 13 pi over 6. Well, 13 pi over 6 is not a unit circle value, but I'm telling you to convert this to rectangular form. Well, if you think about it, 2 pi is equal to 12 pi over 6. So if I go one full rotation by subtracting 2 pi, this is going to be the same as pi over 6. So then you can distribute the 10 first, or just go ahead. Cosine of pi over 6 is root 3 over 2. Sine is 1/2. Don't forget your I. And then I can distribute. So we have 5 root 3 plus 5i. Okay, dividing, we're going to divide the r's, so we're doing 1 divided by 3. So the r value for 1 is 4. The r value for 3 is 5. Cosine, the r, or the theta is pi over 6 minus 9 pi over 6. Okay, so this will be 4/5 cosine negative 8 pi over 6. Which we could reduce to negative 4 pi over 3. Or you could write it as, you could add 2 pi to this, which would be 6 pi over 3 and get 2 pi over 3. Okay, another division with our answer in rectangular. So W3 divided by W2. So we're going to have 5 over 2 cosine. If I subtract 9 pi over 6 minus 4 pi over 6, we get 5 pi over 6. From our unit circle, cosine of 5 pi over 6 is negative root 3 over 2. Sine is positive 1/2. So if I distribute, we're going to have negative 5 root 3 over 4 plus 5/4 I. And then lastly, powers. When we do powers, we take the r and raise it to the power. So we're doing W1 to the third. So we have 4 to the third. Cosine, we're going to multiply the angle by 3. So this is 4 cubed is 64. Cosine, we have 3 pi over 6 plus I sine 3 pi over 6, which is 64 cosine pi over 2 plus I sine pi over 2. We could certainly turn this into rectangular if needed, but we're asked to do polar, so we're good. The last problem is also a power, but it's a rational exponent, so it's really a root. So we'll have 5 to the 1/4, and then cosine, we're going to multiply the 3 pi over 2 times 1/4. So that's going to be 5 to the 1/4. We just leave it like that. We don't know what that is. So we'll have 3 pi over 8 plus I sine 3 pi over 8. So that is your Unit 7 review over polar coordinates.